our this chapter 11 is about quadratic equations and functions. But before that, we need to learn a couple of tools for this chapter, just specific for this chapter, and learn about them. It's called square root property and completing into square, especially the second half of this section, completing into square. Extremely important for this course, and the following course will be using this tool, completing the square. So, and it's various basic stuff. However, you need to pay attention to a couple things. It's dangerous because it's long, and there are spots, if you don't pay attention, you may make a simple mistakes, and it's a costly one because it messes up whole solution. But before that, let's learn something basic first. Square root property. I'm just wondering how we used to solve this question back in 6.7. In 6.7, in chapter 6 especially, you learn how to factor trinomials, binomials, or any kind of equation. You learn how to factor things. So the way we used to solve this is we collect everything into the left side, get right side 0. So we moved 81 to the left, and it was x squared minus 81 equals 0. We got the right side 0 first. This is important. And then once we do that, we try to factor this into two parentheses. And there's a special method to do this because 81 is actually a square. When you have square of something minus square of some other thing, do you recall this property? Square of a number, square of another number with a difference. This is called difference formula. The way you factor this is, anyone? How do you factor it?
9 squared and x squared.
9 squared and x squared is our problem, but with a and b, it's a minus b, a plus b. Right? You take a and b repeated twice, a, b, with a minus and plus. We can flip the order, first plus or minus. So what we have here for a is x, this is your a, and for b is 9. So this is x plus 9, x minus 9, or x minus 9, x plus 9. It doesn't matter which order. Oh, once you factor this, you set each piece into 0. X minus 9 equals 0, x plus 9 equals 0, and you get x equal 9, the first solution. The second solution is x minus 9, and you're all done. This is how we used to solve in chapter 6 with factoring skills. You factor the trinomial or binomial with the simple tricks, and set each part factor into 0 and list the solutions. However, after 6, we learned a chapter called radicals, chapter 10, the previous chapter, radicals, that teaches us how to take care of squares around x's, set it into numbers. There is a weapon that wipes off squares if you combine it. So what is the right weapon to wipe off this square? We didn't know it in chapter 6. This is how we did it. But in chapter 10, we learned that square and something else comes together and they cancel out. What is that? Square root. You can bring a square root to both sides of the equation. However, you need to put plus and minus to the right side. And this 2 and this 2 cancels each other. You have $2 and you pay off the guard, etc. and you get x out. And 81 is the same. 81 is 9 squared. So this guy also have $2, so they cancel out. But you still have plus and minus 9. In other words, x equal 9, x equal minus 9. You can get to the same result. Look, same, right? Just an alternative way using what you just recently learned. This is called, what I did here is called square root property right here. So from now on, when you have a square of a variable or quantity, set it into a number. One side is a number, the other side is variable squared. If a variable squared and set it into number, you can now solve it in 10 seconds. Find the solution in 10 seconds without factoring. All you need to do is set x into positive square root and negative square root. We shortly call it plus minus. Plus option and minus option of 81, which both gives you 9 with a 1 with a plus, 1 with a minus. Plus minus. Does it make sense? We just applied it here, but that's how it's mentioned here in this section. Alright, our first problem is very similar. A variable, look, a variable squared into number. All you need to do is take care of the square by taking square root of both sides. Once with a plus, once with a minus. Look, I set up my equations first. V with a plus square root, V with a minus square root. So what is inside the square root though? 1, 4, 4. 1, 4, 4. And what is square root of 144? Is there a number when you square it becomes 144?
Well,
Yes, it's 12. This is positive 12 and this is minus 12, and we're all set. Okay? Again, if you want to do factoring method, you need to bring this to the left, work it out. It's longer, it works, but they want us to do this by square root property. You just take square root of both sides. Alright, do we have plus? You can go with two options here. You can use plus minus symbol and do 12 here. Or you can type in positive 12 or negative 12 separately. They are the same. Okay? This means plus 12 comma minus 12. Alright. This was an easy type because everything was ready, served, ready. But this one requires more work. Why? To be able to use square root property, you must have the left side squared, the right side number. You must have everything packed under a square on the left. Everything on the left you see must be under a square. Very important. So check out the left side. This is left. Everything you see on the left, I see 2, I see 8, I see 38. Are they all packed under a square? Are they? Do you all see everything under a square? No. I have 38 without a square. I have 2 without a square. The only thing under a square is A. This question is not ready. How do you get it ready? What's that? Perfect. We need to get the square term. Mark it. This is the square term. You need to get this alone on the left. So that means anything besides a square must travel. These green items must travel to the other side. Okay? So how do you move? Which one do you move first? 2 or 38? Yeah. The stuff adding or subtracting travels first. So I need to move 38 to the other side by subtracting, putting opposite to both sides. Look, 38 is moved. You see? To the other side. Now what is next? We need to travel 2. It's division. You need to division 2. And a squared is, what is 38 divided 2? Minus 19. And the last stage is it, now final check. Is this thing alone? Yes. Is this thing a number? Yes. Alone. Square is alone, and a number on the other side. This question is ready for square root property. What does square root property say? All you need to do is split this into two solutions without any square. Square is removed, but you bring in a square root, once with a plus, once with a minus. Agree? Well, what do we have under the square? Minus 19. Are we done? What is different in this question comparing to this one? Yeah, we had a positive number under a square root here. And what we have here is a negative number. What's wrong with negative numbers under a square root? We cannot compute this as a number, a real number. It's not a real number. Then what kind of a number is this thing? If it's not real, we call it complex number. 10.8, the last section we did. This is a complex number. We need to turn this into complex number. I mean, I call this a disease jail. So there is some disease in this jail. You need to cure it. If you leave your answer like this and try to plug it in, it's not gonna work, guys. So if you try this as square root minus 19 with plus minus, it's not gonna work. Incorrect. You see, they don't like the diseased jails. You need to sanitize them. How? You need to cure these negative numbers, negative signs. How do you do that? Pull it out as how? I. Yes, this turns into I 19. This turns into negative already I positive 19 now. You see, I cured the negative signs. So it is, when you combine this, plus minus I root 19. But we like i's on the end better. It doesn't matter. It's both acceptable. I like I after the number square roots. Okay. So to fix this, I move minus as I out. Make sure it's out, not inside the jail. Now we're good. Can you break 19 and save somebody from jail? No, 19 is a prime number. It's not factorable. Okay. Ready for the next question? Again, says square root property. Idea is the same. Square, spot the square. Where is the square? Here. To be able to apply this property, the left side must be entirely under a square. Unfortunately, this guy don't have a square. No square here. If you don't have a square, you need to travel. So travel that minus 5. How? Add 5 to both sides, and there you go. 8m minus 9 squared equals 5. Okay, my question is, shall we travel minus 9 and 8 to the other side and leave only m squared on the left? Shall we? Feels like it's very tempting, right? We need to add 9 and divide by 8. You cannot do it because these guys are under Square jail. This is kind of a jail. Square is guarding them. They won't let them go. So you cannot move 9 and 8 to the other side before killing 8. You need to kill the guard. And guess how you do that? By square root property. So you don't have to move 8 and 9. When you have the left side entirely under a square, you can do square root property. What does it say? It says just kill the power, and set this into square root of the right, with once with a plus, once with a minus. Look, I'm repeating the same thing I did here at the last stage. I killed the power and put it into both sides. Once with a plus of the square root, once with a negative of the square root. Okay? Remove power, set it into square root with a plus and minus. That's it. Does it make sense? Can you follow? So are we done? Is the result root 5 and negative root 5? Root 5 and negative root 5, these are true results? No. Again, solve means, what is the meaning of solve? What is the alternative word for solve? It's isolate the variable. In the end, I need to see the variable all alone on the left side of the equation. Is this variable alone? Is it alone? No, not yet. It has 9 and 8. So we need to move and do a couple more work. I need to first cancel this 9 by adding 9. So it is 8m equals 9 plus 5 is 14. Am I right? Can I add 9 and 5? This is free guy. It's not inside the jail. This is the jail guy. You cannot join them. They don't combine. They are not like. So if they don't combine, how do I put them together then? You just put one first, the second next. That's it. 9 plus 5. Okay? 9 plus 5. Here, I do the same thing here. 8m is this time positive 9. Take away root 5. Okay? Is m completely alone? Not yet. You need to get rid of this 8 by dividing both sides by 8. Oh, I missed this one. Can I divide 9 by 8? No, they don't cancel. So here is our result then. Am I right? 9/8 root 5, or 9/8 minus root 5. If you type this in, there is a surprise waiting for you. So what did we get? 9/8. Oh, isn't this plus and minus the same thing? No, coming up from 9/8. So can I put 9/8 plus minus there? I will just combine them into plus minus square root 5 rather than writing separately. 9/8 minus root 5, 9/8 plus root 5 together here. Oh my god, it's incorrect. Where did I mess up? Yeah, here's the mistake. When you're dividing both sides by a number, this 8 not only divides 9, but also it divides 8. I'm sorry, root 5. 9 and both root 5 are divided by 8. So I need to put this 8 underneath this guy as well. That's the mistake, not the plus minus. Am I right? Still wrong. Where did I mess up again? Where's the mistake?
One fraction.
Hmm?
It'll be one fraction. 9 square root 5 and then over 8.
Oh, you don't want me to split into 8s into 2? No, that's not it. This is still, yeah. This 8 is free, not under jail. But what I typed in here, 5 and 8 are both under the jail. It's not fair. How did you put 8 in there? How do I fix this? Yeah, it worked. So 5 is in, 8 must be out. No. Let's delete this. Not that one. Start with the ratio, put square root first, 5 in there, and 8 is out. 8 must not be in jail. We need to delete this. Okay. Let's check again. Now we're good. Okay? We see the difference, right? Well, you can combine this. I think that it will be still acceptable. I'm not sure.
Plus or minus 9 square root 5 over 8.
Yeah. So let me delete all this and try again. Take the ratio, put 9 plus minus square root 5 over 8. This is also acceptable. You don't have to split into 2 pieces. Yeah. Okay.
But it's wrong if you put plus or minus in front of the 9.
Yes, it's wrong if you put it in front because 9 is always positive. The sign change is only before the radicals. Only plus minus happening before radical, not 9. Okay? Or you can even put these separately. 2 answers. One this, second this. You don't have to use plus minus. Alright, we're skipping number 4. Very similar to number 3. I'm leaving that to you. Number 5 is a multiple choice question. You just need to answer how many solutions you expect to get from this question. How many? You can have 2 real as a number. You can have 2 complex solutions with i's, or you have only 1 real solution. What is given? K is a negative number. So if you wish, pick a negative number and put it right there. What negative number, for example? Minus 1? Okay. Or minus 9, minus 4. Take perfect whole perfect numbers. Don't put 2 because we don't know square root 2. Anyways, you can still do it though. So how many solutions do you expect to get if k is negative, like x squared minus 1? Plus negative 1 makes minus 1. It is. When you put this to the right, take square root of both sides. When I take square root of both sides, square root of 1 and square root negative 1, oh, it's 1 and negative 1. So we expect 2 real solutions. Okay? Alright. The correct solution for this one is A. I want to flip the question, see. Try another one. How about now? This time k is 0. X squared equals 0. How many solutions are you gonna get? K is 0. So you have x squared equals k. Oh, they have provided k to be 0. If this side turns into 0, how many solutions do you get? It's 1. When I take square root of both sides, this is x root 0, x minus root 0, but root 0 and minus root 0 are both 0. So you have a unique solution. This is an exceptional case. If you have a 0 on the right, there is only one unique though. One real solution. Alright, let's try another. What if this is a positive number this time? Pick a positive number, please, such as x squared plus 1 or 9 this time. I move this to the right side and get this. Take square root, 1 positive, 1 negative. How many solutions we have? 2. Since the inside is negative number, this time 2 imaginary solutions. Okay? So we have seen all 3 different solutions, three different cases. Alright, first half of the session is over. Are you okay with square root property? Okay, let's tackle the hard part now. Completing the square is coming up next. How do we complete into squares? You need to first make a big observation. This is very important. From our earlier sections, these are called trinomials. Tri means 3. You see 3 terms here, 1, 2, 3, 1, 2, 3, 1, 2, 3. Some special trinomials can turn into, when you factor them, can turn into, collapse into squares. But some, I say, not all. Those qualified to be a square are called perfect squares. These are special trinomials. Not every trinomial, not every 3 terms turn into square. Our task here is to turn given perfect trinomials into factor form if you're lucky. But let's observe a relation. We start with x squared, 10x and 25, and it turned into x plus 5. We started with t squared minus 6t plus 9, it turned into t minus 3 squared. P squared minus 14p plus 49 turned into p minus 7. I wonder how they discovered these. And I wonder if they are right. Maybe this is wrong. Maybe they are cheating us. How do I know if these two are equal? I want to first justify if they are equal. When I FOIL this, I must get the left side. Let's FOIL it. First terms outside, insert last terms. X times x is x squared. X times 5 is 5x. 5 times x is 5x. They were wrong. This is not making 5 times 5 is 25. This is 1, 2, 3, 4 terms. This is 3 terms, so they are wrong. Are they wrong? No. When you combine the middle 2 terms, they actually make 10x. They were right. They turned this into this and they did it the right way. I wonder, I understand how they got these. They just took the variable here and put it there. I understand how they got square because each term has a square here, x squared, and 25 is even a square. This is 5 squared, 9 is 3 squared, 49 is 7 squared. So I understand squares. What I don't understand is how they got this 5, minus 3 and minus 7, because I don't see those numbers here. I understand x and 2, t and 2, p and 2, but I do not see 5, minus 3 and 7 in here. How did they get it? Any ideas?
Factor.
Factor what?
Well, there's at least common denominator. Is that what it is?
No, that's not the term they're looking for. So how did they get 5 from these numbers then? Look. 25, 5, 10, 5, x squared, 5. 9 is 3. 49 is 7. 14. How did they get it? There is a wrong way of thinking and right way of thinking. My guess is they took square root of 25 and put it here. They figured out what number multiplies itself to 25 and put it here, right? Look, what number multiplies itself to 9? 3. What number multiplies itself to 49? It's 7. Is that how they found it? No, this is wrong. This is wrong because you may think x squared plus 12x plus 49. You may think by that idea this is x plus 7 squared. Because 49 turns into 7, right? Correct? But when you square x plus 7, it's x squared plus 14x plus 49. So they don't match. These two won't match. They found this number. You find this number, sorry, here, not from the last term. This is a trap you guys mostly fall into. Don't look at the last term. They found this term from the middle term. 10, 5, minus 6, minus 3, minus 14, minus 7. How did they find it? They took half of it. Half. 10, take half of it. 5, and they put 5 here. Minus 6, half of minus 6 is minus 2. Minus 14, half of minus 14 is minus 7. They found this second term by taking half, but is this mean we need to completely forget about the last term on the end? No. To be able to call this a perfect square, once you pick a number here and square this back, it needs to make 25, 9, and minus 7. So, when they give me a candidate for perfect square, this is what I do first. I take half of it and put it here. What is half of 12? It's already 6. And don't say this is a perfect square and this is how you do it. Always go back and check. When I square 6, do I get 49? Do I? No. That means this is not a perfect square. Don't try to make it perfect. Don't try to turn into square. It's not. So the story we got here is not all 3 given terms, trinomials, turned into squares. Not all. Some only qualifies. This is one of them. This is not a perfect square. You cannot turn into square. Those whose half is this number, and when you square this number makes the third one, qualify to be perfect square. Okay? Alright. Can you tell me, to make this a perfect square, what n, the number on the tail, supposed to be, has to be? What number n must be so I can call this a perfect square? It turns into a square.
36.
Yes. You take half, and when you square it, it needs to make n. So half of 12 is 6. Square of 6 is 36. Then we can make this into, when you collapse this, this will turn into x plus 6 squared. How did I get 6? By taking half of it. I took half and squared to find it. So what is the missing number for part B? To make this a perfect square, n should be 169. Take half of this, 13 minus 13, but when you square it, it's 169. But when you collapse this into square, it is x minus 13. When I'm writing the square, I'm taking half of this number, not this. Okay? So 169 should be what n should be to make it perfect. And its square, its factored form is x minus 13, not 169. Alright, what is n here? Oh, this one is tricky.
30.25.
Nope, not 30.25. I'm not sure, maybe you're right. Is it? Okay, sorry about that then. You just need to calculate 11 over 2, which is 5.5, and then square it. That answer should be squared. We have a square symbol here. Yeah, 30.25. Yes, you're right. So I take half, which is 5.5, and square it to make 30.25. Alright, the last one is the trickiest one because it's a ratio, minus 4/7. What is half of minus 4/7? This is minus 4/7. You need to take half of it.
2/7.
Yep. 4 and 2 cancels. It becomes minus 2/7. But n, we need to square this, right? How do you guys square it? You square top and bottom, which is 4 over 49. That's it. Any questions? Any questions? Alright, do our homework question now. Number 6. What is n? Should be 5-second question. 16, right? 4 squared is 16. Then factor the trinomial. It says not only call n but also factor it. So you found it. Okay, 16. Check. But what does this factor into? You need to type in its factored form. I know the first one part is y. Y is the variable. But what is the number accompanying y? Plus 4. How? You just take half the middle term, plus 4. Are we good? Next. Look, you don't even need pen or paper for these questions. What is n? Hmm? 12.25. You take the half of the middle term, which is 7 over 2. Divide the term in the middle by 2. And take that answer and square it. 12.25. Again, we take 7 over 2, which is 3.5, and square it. And it's 12.25. Okay, that was easy. How about its factored form? Whoa, wait a minute, it's wrong. Why is it wrong? Did I get it right? Oh, sometimes, okay, this is not a real mistake. Connect Math doesn't like decimals. So, what is the right way then? Don't change this into decimal. 7 over 2 should be squared as a ratio. Square 7 over 2 as a ratio, which is 49 over 4, and don't change it into decimal. Don't change this into 12 over 25. Which is 49 over 4 is just fine. Okay? Now it lacked it. Although the same answer. Okay? Now, they want us to change this into square. So I start with the variable a, and what do I put? What's the number after a? Is it 49 over 4? What is it? What is the number next to a? It is half the middle number, which is 7 over 2. Okay? Are we good? Again, this number is always the middle number, half. The number on the end, to make it perfect, is 49 over 4. These exercises are very important for the real procedure, completing into square. If you don't notice this, that if you don't get this, you will never get the next part, okay? Alright, let's do this one next. Again, don't change into decimal. You take half What is half of 3/4? You combine the denominators, unless you can cancel 3 and 2, we can't. So you combine the denominators, 4 times 2 is 8, 3/8. And then we square it. Square 3/8, 9/64. Square of 3 is 9, square of 8 is 64. That's n. Alright, how do you turn this into square though? Y, what is next? Plus 3 second, 3/2. Is that right? Is that right? Divide by 2 is 3/2. Careful. Yeah, it's 3/8. This is wrong. When you divide, there is already a denominator. When you divide it, that denominator should be bigger. 3/8. Alright, now we are starting the real deal. But I don't want to start it today because it's so long. Why don't we take a quiz?